Today we learn the forming system and temporary structure. So with that, we have three learning objectives: explain shoring and formwork system, and what are the applicable standards that used for the form system and temporary structure. And we estimate the construction loss and select the shoring system for these structures, and then we determine the material costs for formwork and temporary structure, so that we can decide should we buy the materials or we will rent. So there are a few options that we will evaluate, and with that we require the knowledge in the engineering mechanics in project planning for this lesson. So let's start with the applicable standard that we use for this lesson, and of course that will be used for the next three lessons when we have the formwork design 1, 2, 3. So the first one is the OSHA 29 Federal Regulation Register 1926 and Subpart Q that I will show for here. If you go to the OSHA Occupational Safety and Health, and with the part number 1926, that for construction, and Subpart Q is about the concrete and masonry construction, because the formwork we tend to use for the concrete and masonry construction for temporary structure and formwork. The second applicable standard and regulation is ANSI, American National Standard Institute, ASSE, American Society of Safety Engineers, and the standard number is A10-9, the current 2013, and of course it's updated every several years. So that you can see that one here is about the safety requirement for concrete and masonry work. So it's very important concern the safety during the construction concrete work, and especially with the formwork and temporary structure. And the standard that used to design the formwork, how to set up, how to strip or remove the formwork, that is ACI 347, American Concrete Institute number 347. They update every several years. Give example here, that is the version in 14, and guide to formwork for concrete, and that you can see multiple chapter involved. Design part, determine the load, the shore, the bracing, etc. during construction. And then we have materials, architectural concrete, special structure, and special method for construction. All of that related to what we are going to discuss in today's lesson, and especially the next lesson and the following two lessons in next week. So with that is the standard that we use. So let me go to the first few slides to discuss the shoring system and temporary structure that used for especially the concrete construction. For the forming system and temporary structure, as you can see in this figure, we have a formwork to post slab, and also the concrete pumper and tower crane for transfer material, and the hoist to vertically transfer the workers to the top floor to work on. And for that, first we talk about shorings, and in terms of shoring, sometimes we can use scaffold to play at the shore, as you can see in this picture, and this is the scaffold, and we can set up for placing the concrete on the floor on the top here, and this is the floor it already placed, and the column, concrete column, as you can see. And with that we need to have some adjustment for the height added in the scaffold when it placed at the shore. In terms of shoring, there are multiple types. As you can see, this is the used scaffold at the shore, as just mentioned earlier, with different standard, different sizes and dimensions. And then we have the standard post shores, as you can see here, and go with it is the allowable working load with the height. Depends on the height, what are the working load. And of course, we also have other type of saw I can have here. And of course, the saw can be able to adjust the height, depends on the requirement for the clearance from floor to the ceiling of the structure. And what are the forces apply on the soldering system? The question will answer for your question depends on what is the applications of the saw that you use. If you grip saw, the load is vertical and the reaction goes top. If we use the saw for set up the formwork system and temporary structure for placing the slab, concrete slab, then you will have the concrete dead load, the formwork load, and also the live load that worker working on, equipment working on. And then you have a reaction from the ground floor or from the floor, concrete floor already placed on the saw. So that is the load applied. And then if we use the tower saw set up in a higher place, and the load it can be to be a vertical directly on the saw. If we use the saw to support the horizontal pressure, example include that we use the saw to support the form system for the wall or for columns, then you will have a regular saw. And of course, something other application we discussed earlier of this class is we use for the excavation. So you use the saw to support in the trench excavation, for example. So as I mentioned earlier, each saw which depends on the height. It have a allowable working load, and that call it here AWL, and in this case in kips. So in this graphic we have 4 different type of saw, and as you can see 4 feet 11 inches leg, and then it go to 13 feet and 1.5 leg, and each of that have a range of application. If we for example the 4 feet 11 inches leg, the application in terms of the height is somewhere, as you can see here, from 5.5 feet to go to 9 feet. But then if you want a higher clearance, let's see, use from floor to ceiling is more than 14 feet. So probably we need to choose the saw with the 13 feet and 1.5 inches leg. And that is only one manufacturer. On other manufacturer will provide allowable working loads with similar graphic for their products. We will get back to this in problem 1 to read and to choose the saw for a specific application after this lesson video. And then how to assemble a frame sawing. So as you can see here, the first we can set up and put brace, because that the saw may have some horizontal load just like wind, etc. And then we can put more the brace in, and then if that height is not enough, we can put another module on with the similar assembly and keep continue to do that to stack a higher position so that you can meet the requirement height from the floor to the ceiling of the next floor. And as you can see, shoring and reshoring, what is that about? In this case, this is a table form that we will discuss in another lesson video in today's class. We will talk about formwork later on. But then you cannot, and that you learn in the civil engineering materials, the concrete will not get the strength of the intended design strength 28 days or after. But it's not economical if we place the stable form here for 28 days until it gets strength. So if you need that, you need to a lot of material, a lot of the formwork to set up for to wait for 28 days to remove. Just give you an example. Typically we need only 7 days to move one floor to another, to finish one floor of concrete construction, including column, slab, beam, etc. And then if we wait for 28 days, mean that we need at least 4 set of forms. So that become uneconomical. You're not competitive. So what people do is to get some strength of the concrete, they can remove the taper form and replace with the shoring, and that one we call it the one here. After remove the formwork, we put the shoring. We're talking about reshoring or backshore, so that have some support for the new concrete that is not gain enough strength as intended by the structural designer. So that we call it shoring. It means before we place concrete, after we remove the formwork, push another saw in, we call it reshore or backshore. And the place where to put the backshore is very important. That we show you the common problems of reshoring in a few minutes. So common shoring problems. The first one, as you can see here, is the adjustment, because the height is very important. If we are not adjust correctly, then the height from the floor to the ceiling, it will not as intended by the designer. And with that one, what happened if we are not changed accordingly? So if we have the slab here, and this straw, and you can see because that it not tied into the structure or beams of the formwork correctly, then if we place concrete in one place, and because this is the formwork, so it's easy to deflect or bend it. And if we bend in here, if nothing tied to that formwork, it will be fall out, and that it will be causing the cascading effect. So if you have here, then it's not enough to support this shore, it will be collapsed the whole temporary structure and the formwork. And of course, it may have some casualty if the worker working on that slab. The second problem related to the shorings, and as you can see here, if we are not going to brace between the shore, so the shore is very good at, as you can see here, have a compression load, so the vertical load. What if we have a just very gentle wind, or someone just, or the equipment hit that temporary structure, then it will have, because no bracing, so it no allowable for the withstand the horizontal load, then the whole system, including the shore, the formwork, and the concrete, and the worker, it will be collapsed. So that very dangerous situation. Enough bracing is very important. Something that we are not looking at when you design the shore, only focus on the concrete load, the worker, the live load on it, but not about the wind, etc. And the third problem related to the adjustment here, and you can see it out of the vertical, so it can have the eccentric load, and that will be disaster if we only just change the direction of the load. It can be make this one locally collapse, and when it locally collapse, it can lead to other shoring collapse, and that will be collapsing the whole formwork system. And that it also apply in the trench. And we talked earlier about the shoring and reshoring, and that very important. We not randomly put the reshore anywhere. We have to be cautious. So this one, as you can see, the top floor, we place concrete, so we need to have the shores, and we have the stringer, we have the plywood, so that we can put the concrete on. But then we remove the form underneath in the previous floor, and that floor is not gaining the enough strength. And if we reshore that at some place that not directly below the shoring, you can see here, so the way that create the load, and also the bending moment, and consequently the deflection on the slab are not as intended. So as you can see in this case, it creates additional support in there, but then it will deflect on the other place. And when it deflect on the other way, that may not be the intended design from the structural designer. Okay, because that when you design the concrete or any structure, we assume what other loads should be after construction during the permanent structure when the structure put it in use. But this is during the construction. We make sure that it will not create the load that cannot be anticipated during the design. So this is one of them. Get deflection, because normally when we design, we assume the slab, if we work this way, deflect maximum deflection in the middle, but in this case it go up, so that opposite to where you put the rebar, etc. Because we tend to put the rebar on the area that have a tension, because the concrete not good at tension but good at compression. In this case, the designer tend to put the rebar underneath here, but then if you put the resort there, it will tension on top, and that may not be anticipated during the design. So as you can see, so how to solve the problem? We need to resort underneath the shore system so that we will not create any additional load or change the way the structure work compared to what the designer model. So that is the first one. And the second consequence, if you resort that, and then it will make a deflection, change it differently, and when it differently in the middle it go up, then the shoring may fall down, because the resoring may fall down because it's not enough the height, so that it will fall down. And when it fall down, the concrete is not gaining good strength as intended. It may collapse, and that collapse, as you can see, it got disaster for the whole building. So those are the common problem. And the last common problem is, what are the sequence where I should remove the shoring and the formwork. The incorrect way, you start from the corner, so there's from the support, and that will create a new way the structure, the slab and the beam work. So the issue is how to remove the formwork that makes sure the way that the slab or the beam work similar to after the building put it in use. That's what the designer designed for. So you start to strip or to remove the formwork and the shoring in the middle, so that, as you can see, deflect go down here, and that's same as what the designer intended. Okay, but in this way it will be there. So just in the middle here, it will have the chain, the positive and negative moment, and also the deflection at this point, so that it's not intended. So here it will be deflection down, same as intention, and then it continue, it will be on the whole thing, it deflection down here. That is what the designer intended to design. So as you can see, very important during construction, make sure we don't create additional load that substantially opposed to what the designer intended to design when the building bring it into occupation. So with that, we go back to problem one, to show the problem, to determine the load, to choose the source, and then we go back to talk about the formwork system, and then material cost for the formwork system.